This is Heather from World Class Tutoring, and I am making this video to help you get better at using Desmos as a tool when you are taking the math part of your SAT. And we have 10 questions that we're going to do together today. I do have a copy of this worksheet. I recommend you download the worksheet first and try it on your own, and then watch this video second after you've given them a try. And so please go to worldclasstutoring.com and find that worksheet so that you can try it first. Once you're ready, continue with this video and we're going to do all 10 of these questions together. All right, so starting with question number one, this is probably not too hard to do by hand. I'm going to focus on doing them on Desmos, but please know that if you see a way to do this on hand that's even faster, that's totally legitimate, and choose the best way that you're going to get the right answer. I am going to show you the Desmos way for each of these questions. So first of all, if you haven't already, open up a tab at desmos.com, Desmos, and click on Graphing Calculator. You'll get a screen just like this. You could also download the Desmos app on your phone and use it on your phone. Or if you're using like the Blue Book app or at World Class Tutoring, if you're doing some of the practice problems there, if you're one of our members and you can get to that area, there's the built-in Desmos. It's all exactly the same and it works just the way I'm going to show you here. Okay, and what we have is, in this particular question, we have a graph, we have 4 equations, and so I am, of course, take a moment to read it, but I'm going to type in all 4 equations and just see which one matches this graph. All right, so equation A is 4x plus 2y equals 100. 2x plus 4y equals 100. Y equals 2x plus 50. And y equals negative 2x minus 50. And we can see lines everywhere on this graph. It's kind of hard to tell. So I do recommend you use the circles next to each line to turn them off. And then one by one, you can turn them back on just to see where they have appeared. And what I'm looking for is a line that is going in the same direction as my original. And I'm also going to check those intercepts in case in case the scale doesn't quite match up. But it does look like this one here. It looks like 50 and 50 match up. And this looks like at the bottom here, the x-intercept about 25. Look at that, it's 25. A is my answer. It was the first one. All right, let's try the next one. What is one of the solutions to the given equation? This doesn't look like it's a graphing question, but I'll tell you, you can solve any equation that has one variable. You can solve it on Desmos using this technique. So let me get rid of the last question. What I'm going to do with an equation that only has one variable, I'm going to give it 2 variables so it graphs nicely with me. That means I'm going to start with y equals, and I'm going to type that twice. And then I'm going to type the first half of this equation, x squared plus 3x minus 28. And I'm going to type the second half of this equation. In this case, it's just 0. And the solutions, let me zoom in a little bit. And by the way, I recommend when you take the SAT, get yourself a good mouse that has a little scroll so that you can zoom in and out very easily with Desmos. It's great to have the right tool for the job. So let's see here. I have -7 and +4 as my 2 solutions to this equation. Remember, this original equation only had an x. There was no y. I put the y in so it would graph more nicely. So I'm going to ignore the y coordinates of my solutions and only look at the x coordinates. And it says, the question here says, what is one of the solutions? Well, both of them are, I know, it's negative x, it's -7 and +4. Those are the 2 correct answers. It's a little frustrating when you know both of the answers and the SAT only allows you to report one of them. It does not matter which one you report. You'll get it right either way, so I'll pick the 4. If you had chosen to put the -7, that's also a correct answer. But you can't put them both. You have to pick one. All right, let's move on to the next question. Number 3, this time I have a system. I've got 2 equations with 2 variables. I don't have to put in a y because it's already there. So I'm just going to type it exactly as is. Again, the solution is your intersection point. Y equals 3x, 5x plus y equals negative 16. And my intersection point is right here, negative 2, negative 6. Now this time the x and the y were in the original question. So I do have to reread the question carefully. It could ask me for x or it could ask me for y. You just have to read and look. In this case, they want to know what is x, and x is negative 2. But if you had chosen the negative 6, you would have been sorry. That would have been a wrong answer. This is so be careful with that. This is B, and always go back and read that question one more time to make sure you choose the answer carefully. Desmos gives you a lot of numbers. You only need one of them. All right, let's look at number 4. This time we have an A, right? This is new. Let's give it a try and see how this is going to work. There are no y's, so I am going to start with y equals and and cut this equation in half. So the first half is 5x squared minus ax. And as soon as you get an x and a y and then there's a third letter, it's going to ask if you want to add a slider. Yes, we do want to add a slider. So I'm going to click on that A. And now I'm going to get this slider that moves around. I know we can't see much yet, but we will soon. Let me just finish typing this. It's just y equals 0 is the second side of our equation. Now I can't see a black line, and that's because of that plus 64. I've got to zoom way out so I can get as high as 64, and then I should be able to see the thing. Here it is. All right, so it was just up too high, and I had to zoom to see it. And now let me figure out what was going on with this A. I see if I move my slider, it changes the value of A, and that kind of moves this equation around a little bit. I can see the parabola changes, but it doesn't get anywhere near my red line. Let's see. For which of the following values of A will the equation have more than one real solution? Well, my first option is negative 39. So I'm going to go to the slider and just type in the number negative 39. I think that's the fastest way to get there. And I can see now my black parabola does cross over that red line twice. That is more than one real solution. I can see 2 of them right there. I believe the answer is A. I am, just because I'm a double checker, I'm going to check the other 3 answers, but I'm pretty sure it's going to be A. Let's see. If A was 5, I don't even see, I have to zoom out again to see it. Nope, there's no way that black parabola is getting near that red line, so no solutions there. No solutions if I change it to 8. No solutions if I change it to 20. So A, negative 39 is definitely my answer. Let me just show you one more time. That's what 2 solutions looks like. 2 crossing points here. All right, let's move on to number 5. The graph of 5x plus 7y equals negative 21. And they have a lot of things to say about this, but Desmos is going to help us figure it all out. Let me get rid of the last question. Let's graph this. 5x plus 7y equals negative 21. And I'm going to zoom in because I can see they are talking about the x-intercept and the y-intercept. So the x-intercept is right here, right? Negative 4.2. And they're telling me that is the value of A. A is negative 4.2. All right, and the y-intercept is down here, and that is the value of B. B is negative 3. And the question is, what is the value of B over A? So Desmos is going to help me one more time. You know, Desmos does more than graph. It also calculates for you. So I've got a negative 3 divided by negative 4.2. And I get this nice fraction, but guess what? Desmos is good at fractions too. You see this little button that has it it looks like a fraction, right? With a square over a square. If we push that, my decimal answer turns into a fractional answer. This is just a toggle. It goes from a decimal to a fraction for you. And for this question, we want the fraction, 5 over 7. All right, let's keep going. Oops, I went too far. All right, number 6. Here we have a system where n is a constant. So we got lots of variables and constants going on here. And it specifically says no solution. When you see this, That means no intersection. All right, let's see what's going on here. I'm going to type in 5x plus 9y equals 5y plus 28. And ny, we're going to end up with a slider for this. Ny equals negative 20x minus 48. All right, well, I'm looking for no intersection between this red and black line, and I got an intersection. Right? So what I'm going to do is move this back and forth until I don't have an intersection. And by the way, the word for this is parallel. I'm trying to get these two lines parallel. And I can see that this particular slider is not big enough for me to get to where it might be parallel. I think I want to go more this way. So I am going to change the endpoints. Let's see, I'm going to have negative 10 being the highest endpoint, and let's go down to negative 20 and see if that gets me anywhere. Oh, I'm getting closer. Not there yet. I should have, hold on, let me make sure I typed everything correctly. I did make a mistake. Look at that, because I wasn't matching my answer key. I mistyped 5x plus, it should be a 5x plus 9y. Well, that explains my problems. Let me try this again. I'm still not getting. Ah, I see now I have to change my slider to the positives. So we're going to go from 10 to 20. Oh, this is what happens even when you practice first. All right, now I can see I'm very close to parallel lines, right? And I've got to get these lines parallel as close as I can. And it looks like it's right there where these lines are perfectly parallel, but it's hard to tell. If I zoom out, it's a little bit easier because I can see the where the ends get a little too close to each other. Yeah, this right here at 16, and I'll zoom out even further. The space between my red and my black up top and the space between my red and the black down bottom, they look like they're equal spaces. I think I got the perfect place where these are parallel. It took me a few tries. I had to retype it, but we're there. N is equal to 16. And that's the question here. It doesn't say what is X or Y. It says what is N. And my slider here is telling me that N is equal to 16. This is going to be my answer. All right. By the way, I think this particular question, if you know how to do it by hand, right? Solve for y and then check that the two slopes are equal. I do think that's the better way for this question. However, because it's a Desmos presentation, I wanted to show you the Desmos way. But even though there is a way on Desmos, I'm not convinced it's the best way for this particular question, but it'll work in a pinch. So I did show you how you can make it work. All right, let's look at number 7. The functions f and g, I see, are defined below. X is greater than or equal to 0. Which of the following equations displays as a constant or coefficient? Oh, these words confuse everybody, but there, once you see what they mean, it's so easy. But you have to see what they mean, that you can see the number in black and white as one of the numbers in the equation. So, and in this case, the number you're looking for is the maximum. So let's start with f of x. All right, f of x equals 27 times 0.2 times 0.2, oops, 2. And then the exponent is x minus 1. And this is a little funny. I can't type x minus 1 as an exponent. Every time I type the minus, it goes back down to the main level, not the exponent level. My trick here is forget the x, just do the minus 1. and then put the X in later. I know it's such a little thing, but I've seen a lot of students get frustrated by that. All right, so let's make sure I typed it correctly. 27 times point. Oh, see, I didn't. I put my 0 in the wrong spot. All right, that's a little bit better. Um, so the maximum value when X is greater than or equal to 0. So I'm only interested in the right-hand side of the y-axis where X is greater than or equal to 0. And I can see that from the y-intercept, and Desmos shows you where it is if you click on it, which is really nice. Here's the y-intercept. We are only going down from there. So in the area that X is greater than or equal to 0, the maximum value is 27. It never gets bigger, right? So the question is 27 one of the numbers in my equation? So I can see that the max equals 27, and that 27 is displayed, is like visible. That's literally what they mean in the equation. Yes, it is. All right, so we got one is correct. We can at least get that B and D out as options, but I do have to decide for the G of X. So let's just hide F of X for a minute here. G of X equals 27 times 0.25. And the exponent is X plus 2. I know it's weird, but I'm going to write the plus 2 first and then put in the X. It looks similar to the last one, where we're going to start at the y-axis where X is greater than or equal to 0. This is where X is equal to 0. And I can see when X gets bigger, we are moving to the right. We never go higher. So the Y value never goes higher, never goes up. 1.688 is the maximum here. And that is not 27. That is not 0.25. That is not 2. It is not any of the numbers in this equation. So we're going to say no for Roman numeral 2. And our answer is A. All right, let's try number 8. Okay, so for this equation, the function T gives a temperature in Fahrenheit that corresponds to X in kelvins. If a temperature is increased by 5.4 kelvins, by how much did it increase in degrees Fahrenheit? So what we're going to do is we're going to type this equation into Desmos. We have f of x equals 9 over 5. And if you've done a lot of science, this might look familiar to you. 273 is that Kelvin number we're always using, plus 32, 32 for that Fahrenheit again. All right, so now we want to do the stuff about increasing it by 5.4 kelvins. So best my best plan here is when I wrote F, I could have written T. It doesn't matter. Okay. What I'm going to do is I'm going to get T of 1. And I know what that is. That's negative 457.87. And I want to now increase that by 5.4. So 1 plus 5.4 is 6.4. And now I have seen how the degrees changed in Fahrenheit after I changed it by 5.4 in Kelvin. And so I want to find the difference between these two answers. And Desmos is a calculator. It can just do the subtraction for me. So it's going to, I'm going to do the negative 457.87 minus negative 448.15. And I'm getting here, oh, I should have done it in the other order and gotten a positive. That's okay. It does tell me there was an increase. So I will ignore that negative there. Next time I make this video, I'll put them in the other order. But this is going to be 9.72. And look, that's very satisfying when you see a perfect match. I don't like that I had a negative in my answer and not in the A that I circled, but I understand that's because I typed these numbers in the wrong order. Next time I'll type them in the other order, and that will be better. and it would be a positive 9.72. So I'm happy. I'm happy with this one. And I just wanted to show you how, look, we never graphed anything. We didn't use the graphing part of Desmos, but we used the function notation, and we also just used the calculator part, and we're able to solve everything here. All right, let's try the next one, number 9. We have another big old function. This is a toy car and is following a parabolic motion. Um, and it looks like it's moving on a track for probably from 0 to 10. I'm guessing that's 10 seconds. And is starting at 15, so it's going something like this and coming back up. So right here is our 15 at the starting point. All right, well, I can draw a picture on the screen, but I could also have Desmos draw it for me. That seems like it would make more sense. F of x equals 1/5 times x minus 8 squared plus 15. All right, there it is. I just have to zoom a little bit. All right. Oh, that was, oh, all right. Desmos did a better job graphing it than I did because Desmos realized that the this was in vertex form. So the 15 was not the y-intercept, it was the vertex. Look at that, I'm depending on Desmos too much. I'm gonna erase this graph so it doesn't confuse you. Desmos is better. All right, so let's talk about what this means. What is the best interpretation of the vertex of this graph? Well, it looks to me like the beginning. I kind of do have to draw it just so that you can because I can't write on Desmos the way I have things set up here. Right? This is the start. This is the vertex. This is the one we're looking at. Um, and so it looks like it's the lowest point, right? And it's not at the beginning though. It's a few seconds in. It's literally 8 seconds in, and it got as low as 15. Um, right? So it looks like the toy car's minimum height was 15 right here. Remember, 8 is your time, and 15 is the height. So that's the one we're going for, B. Not 8 because 8 was the time. 8 was the well, it was not 8 when it started moving. We can see here it started at 27.8, and the car's height was 15 when it started moving. In fact, if I hadn't used Desmos, I would have fallen for that. I might have picked D by mistake. But that's not true. It was 27.8 when it started moving. So B is the correct answer. All right, last question. What is the sum of solutions to the given equation? Oh, if you know that quick by hand, I think it's a negative B over A formula. You can do this kind of fast, but you know what? Unbelievably, Desmos is faster. I used to love that negative B over A shortcut. Now I use Desmos instead. So let's do our y equals. Y equals x times 3x minus 13. That's the first side of our equation. The other side of our equation is 4 times x plus 7. And I can see my two solutions. Be careful, it is not the intercept, it is the two intersections. Those are the points I'm going to select. My solutions are these two x values here. I can see that 0.333, that's a third. So this is negative 1 and 1/3 and positive 7. Desmos can even add those up for me. Yeah, so let's do it. It's going to be the sum of solutions is, one more time, negative 1.333 and positive 7. And I'm getting 5.667, and that is a good answer. I could change it into a decimal, although I don't think that's a perfect one because I know that 0.33 is actually 1/3. So I'm going to keep it as this decimal. I understand that this decimal is rounded. The rule on the SAT is that you want to use 5 characters to fill this box, and the decimal point is one of those characters. So 5.667. That is 5 characters. Desmos rounded it correctly for me, so that's what I'm going to type in. Okay. Don't leave any of those numbers off. If you round it even one decimal less, then it's going to give you a wrong answer, right? Because that's not the correct you have to use the whole box, right? You have to use all 5 characters. But this indeed does use the whole box, and this is the correct answer, 5.667. All right, I hope you learned something good in this video. It was fun doing this with you. Please visit us at World Class Tutoring. We teach classes every weekend, and all of our students do, well, not a guarantee, but our students do great on the SAT and learn a lot, and I hope to see you there in class. Bye now.